So anyway, the more fun thing to do is to go from the written sequence to the explicit formula. So for example, what if I had 1 for 27, 256. If you're watching, play along at home. I have this sequence right here, and I want to write it in explicit form. We'll represent this sequence with an explicit formula. What do you guys think? This is the small money round. 1 for 27, 256. One question you could ask is what number is next? The real question is what's the pattern? What's the explicit form? Maybe we'll come back to this one. Let's do an easier one first to show how, just show the process. So what if we had, instead of that, we had maybe, let's say 3, 8, 13, 18, 23, 28, 33, on and on like that. How would you write this with an explicit formula? So what's the pattern here? So this is Safa with the broken mic and chat. Oh, is Safa talking?
I thought it was. I thought I heard something and it was unmuted.
I plus 5. I totally see where you're getting at here, Safa. What Safa's saying by I plus 5 is what he means is notice that every time, like you should add 5 to the next one. So at 3, add 5, you get to 8. So at 8, add 5, you get to 13. 13 add 5, you get to 18. 18 add 5, you get to 23. 23 add 5, you get to 28. 20 add 5, you get to 33. But that's the pattern for sure, right? And the only reason it looks weird with 3, 8, 3, 8, 3, 8, 3 is because 5 plus 5 is 10. So it's going to be kind of repeating every 2. Repeating the last digit every 2. But anyway, the point is, yeah, you're totally adding 5. But that's not really an explicit formula, right? What we really want to do is you want to write AI equals something, some function of I, for all I greater than or equal to something. So if you add 5 every time, maybe a good starting place would be AI equals 3 plus what? If you add 5 every time, to get from 3 to 8, you add 5 once. To get to 13, you have to add 5 twice. 8, you have to add 5 3 times. So I have to add 1 times 5, add 2 times 5, add 3 times 5, add 4 times 5, add 5 times 5, add 6 times 5. Is anyone starting to see a pattern? Yeah. You do 3 plus 5i. It's all right, Safa. The chat's working just fine. So the point is, yeah, you 3 times plus 5i. And where do you want I to start? Now this one we can just kind of guess and check, right? Like if we had I start at 0, or sorry, if we had I start at 1, well then we'd have their first term be a1 equals 3 plus 5 times 1, which is 8. But we don't want 8 to be the first term, we want 3 to be the first term. If we were to start at 2, we get our first term to be a2, which is 3 plus 5 times 2, which equals 13. Also no good. If we start at -1, we get a -1 equals 3 plus 5 times -1, which equals -2. Also no good. So what should I be greater than or equal to?
0.
0, exactly, right? If we have I equal to 0, then we see we get a0 is 3 plus 5 times 0, which is perfect. We started at 3, but the very first term we want to add nothing. So that's exactly what we're doing, because 5 times 0 is 0, so we're adding nothing. And then we get a 1 is 3 plus 1 times 5. So we add 1 5 to 3, which gets us 8. A2 is 3 plus 5 times 2. So we add 2 5s to 3, which gets us 13. A3 is 3 plus 5 times 3. So we add 3 5s to 13 to get 18. And it goes on and on and on like that. So here's the explicit form given this written sequence. And as we talked about, there's infinitely many ways that we could write this if we shifted where we started back by 1 or then like shifted this up by 1 or whatever. But as long as one of them works. So for example, you could have chosen also an alternative would be if we had AI equals 3, or we could have, 3 plus 5 times I plus 1 for all I greater than or equal to -1. Or we could have AI equals 3 plus 5 I minus 1 for all I greater than or equal to 1. If you work those out, you'll see that these represent the same sequence. Let's do another one. Let's do 3, 7, 15, 31, 63. Now I'll give you a hint. These numbers look slightly familiar to you because you guys are CS majors. Or if you're a CS major. Not presuming anything. So what's the pattern here?
Three, 7, 5. And then you have 3, 6, 9, but then these second digits would be 1, 3, 5. I forgot, but I remember this is very familiar.
Well, what do these look close to? Or maybe you start here.
Is it,
Between 3 and
sorry,
7.
is it like 3 plus 3 plus 1? And then 7 plus 7 plus 1? 15 plus 15 plus 1?
It actually works out to be that. Yeah, it does. So the difference here is 4. The difference here is 8. The difference here is 16. The difference here is 32. What are these numbers?
Multiples of 4?
Well, they all are multiples of 4, but
Or is it
Some
2?
multiple 4s are missing, like 12's not here, and 20's not here.
Exponentials of 2.
Their powers are 2. Right?
Or is it 2?
Yeah, exponentials of 2. Exactly, Afra. Yeah, powers of 2. So really, I guess you could start at 3 and add powers of 2. But wait a minute. What is 3 but 4 minus 1? What is 7 but 8 minus 1? What is 15 but 16 minus 1? What is 31 but 32 minus 1? What is 63 but 64 minus 1? Right? AI here, you really think about it as equaling 2 to the I minus 1. So power 2 minus 1. The only tricky thing is, where does it start? What's our first power of 2? What should I start at?
2.
So if we have 3 here, that would mean our sequence goes, and you can always guess and check. So you add 3 here, we get A3 equals 2, 3 minus 1, which is 7. And the next term would be A4 is 2 to the 4 minus 1, which is 16. Next term is A5 equals 2 to the 5 minus 1, which equals 31. Is that what we want?
We start with 2 so that we get to the power 2 plus 2.
Exactly. We want to start with 2 instead of 3. Because then we get A2, the first term, to be 2 to the squared minus 1, which is 3. Bingo. That's what we wanted. A3 is 2, 3 minus 1, which equals 7. Bingo again. 2 bingos. Rare in any bingo tournament. The point is, yes. This was form of this, and again, you can write multiple ways. So this is kind of fun. This should be kind of fun. This is back to like elementary school, find the pattern things, you know? Ever read Highlights magazine in a dentist office, something like that? Goofus and Gallant, find the pattern. I don't know. It's fun. What's next? See, interesting enough, mathematics has a lot of patterns. And science has a lot of patterns. And mathematics starts from axioms, things you assume. Science starts from maybe first principles, you should say. Like there's like the laws of physics and things like that. Like gravity, if you start with gravity, you can explain the motion of the planets. You know, like if you take gravity as like an axiom kind of thing. The point is, axioms lead to assumptions. Or sorry, axioms lead to patterns. Science is about observing patterns and trying to figure out what the axioms in the universe are. Math, we kind of already have the axioms. We're kind of observing how they make patterns. It's kind of an interesting reversal. But anyway, so what if we have, we're doing kind of science right now. So what if we have, this is the first one I wrote down, 1, 4, 27, 256. So let's start here. This number 27, I think, is the key to understanding this. What do you know about 27? Just start naming facts about it.
The pattern looks like I to the power I.
Never mind with all the explanation. Exactly, Afra. Right? What I was gonna say is 27, it's like 9 squared. No, that's not right. 27 is a perfect cube. It's 3 cubed. Well, wait, 4 is 2 squared. 1 is 1 to the 1. 256 is actually going to be 4 raised to the 4. The pattern here is that this is AI equals I raised to the I power. And where do we want I to start?
1.
Exactly, 1. So here's how you go from written sequences to explicit forms. It's harder. Right? Explicit forms are written sequences, plug in, you're done. But this, you're trying to find the thing that you can plug into to get to the written sequence. So it's a lot harder. It takes more creativity and more thinking, but it's also more rewarding. But also it's more useful because there's usually kind of hardly any point of writing a sequence out and like written like this. There's really hardly any point in writing it out like that because it doesn't really tell us much. It just is. Whereas this tells us the pattern. Like this is the written form of the pattern. It's 3 plus 5 times I. It's much more useful trying to prove anything about it. Any questions?